Okay, so we're going to be naming a polynomial. That's what classifying means, is name the polynomial. So the first things first, before you can name a polynomial, it has to be in standard form, highest degree to lowest degree. And we have to make sure all like terms are combined. So it's in the most simplified form and in standard form. So once you have a polynomial in standard form and the most simplified form, it has a specific name. And it has two names. The first name that you give it will depend by the degree. And we always look at the highest degree. Degree meaning, like, for example, x to the nth power. We're going to be looking at the degree. The highest degree. That's the only one that matters. And then second, the second name. So a polynomial has two names. First name by degree. And then the second name is by the number of terms. So remember, terms are separated by plus and minus signs. So this would be like 1, 2, 3, 4 terms here, separated by plus and minus signs. Is everybody okay with terms? What?
All we do is say how many terms.
Yep, so we first give it its name by degree, then we give its name by the number of terms it has. And there's specific names for each level of degree and each number of terms, and here they are. You can either write it down quickly or take a picture. I wouldn't want to write this down. I'd want just a picture, so I'll give you a second to do that. So the multitask while you do it. The first degree, the first name is by the degree. We're looking at the highest. If it's degree 1, it's considered linear. If it's degree 2, it's considered quadratic. If it's degree 3, it's considered cubic. If it's degree 4, it's quartic. Now an easy way to remember quartic, guys, 4 quarts in a gallon, right? 4, so quartic. And then degree 5 is quintic. An easy way that helps me remember quintic is, I mean, you guys are kind of young for this, but does anyone remember, and the older I get, the more likely it is that you haven't heard of it. On the Disney Channel, there was a show called Quints. Any of you heard of it? Okay, so one person. You guys are just right out of that age group. Okay, last year my students had heard of it still. It was about this girl that her mom had 5 babies, and it's called quints. So quint is degree 5, so that hopefully that'll help you remember. If you have quints, that means you have 5 babies, so quintic. And then anything higher than degree 5, it doesn't have a specific name. It's just 6th degree, 7th degree, 8th degree, 9th degree. Does that make sense, everybody? So these are the names you'll give it depending. So linear would be degree 1, so like x. Right, everybody? That's degree 1. Degree 2 would be quadratic, so x squared. Cubic, x cubed. Quartic, x to the 4th. And quintic, x to the 5th. Anything higher, it's just 6th degree, 7th degree. So then the second name is the number of terms. If there's 1 term, it's called a monomial. If it has 2 terms, it's a binomial. 3 terms, it's a trinomial. 4 terms, it's a polynomial of 4 terms. 5 terms, polynomial of 5 terms. 6 terms, polynomial of 6 terms. So there's only specific names for up to 3 on this one. Otherwise, it's just polynomial of 4 terms. Now notice these, the second name is always the eals. The monomial, binomial, trinomials. So anyways, hopefully that will help you remember. Does everybody have a picture of this? You're going to have to refer back to your picture until the test comes. You don't have to have it memorized. But most people, once they practiced it enough, they just can see it because they've seen the name so many times they're good with it. All right, are we all okay to start practicing these? Hey, group 1, are you guys with me? Because, you know, I shouldn't even let Mason move if you're going to sit and chit-chat. So are you guys good? Ready to pay attention? Okay. All right, so let's write these in standard form, then classify the polynomial. So look at my first example. 6x cubed. Is it in standard form? Yeah. Is there anything else that I need to do? No. All right, so first name is by the degree. So what degree is it?
Cubic.
3, so it's cubic. It's a cubic, and then how many terms do we have? 1, so it's a monomial. This is a cubic monomial. Is everybody okay with that? Questions on why this is a cubic monomial?
Yes.
Okay, let's look at this next one. Most important thing, put it in standard form, combine like terms, make sure it's simplified before we name it. So 2x squared, no other x squareds. Then I'm adding up x minus 2x, which is negative x minus 3. Okay, Now it's in standard form, most simplified. So let's let's name it. So you look at the highest degree. So what is it?
Quadratic.
It's quadratic. And then how many terms? 1, 2, 3. So it's a quadratic trinomial. Is everybody catching my drift here?
I'm catching your drift.
Okay, awesome. Negative 5x cubed plus 2x minus x. The first important thing, and they will do this to trick you. They'll make sure that they do something that you have to simplify first. So we need to put it in standard form. Negative 5x cubed, and then 2x minus 1x is plus 1x, right? All right, let's name it. It's a cubic binomial, 2 terms. Questions? Okay, this one, negative 4 plus 9x. Is it in standard form? Nope. We got to put it in standard form. So it should be 9x minus 4, right?
Polynomial.
And it is a binomial. What's the first name?
Linear.
Good. Linear binomial. Okay, very good. Any questions on how to name a polynomial? I'm not going to do any more examples then. So I'm not going to name those. Do problems 11 through 19. Ready, set, go. Shit on the board. Okay, so a couple new things here, a couple not new things. So it says, describe the end behavior. We've done end behavior a ton in here. And then describe the number of turning points that you have in the graph. And we have not talked about turning points. That's why we're doing this today. And then we're also going to specify the increasing and decreasing intervals. So also new to us.
Decreasing.
Degreasing, yes. That's a new math thing, if you didn't know. Decreasing. I'm not going to fix it. All right. So let's go ahead and do this. So now the easiest way to do end behavior, guys, is to graph it and then look at your end behavior. So in words, so everybody type this into your calculator. 3x minus x cubed. So type it in. So 3x minus x cubed. So my end behavior from left to right is up and down. So that was pretty easy, that part. So we're answering the first part, up and down. Is everybody okay with that? So it kind of looks like just a rough sketch like this, right, everybody? So it's up and down. All right, so now it says the number of turning points. So turning points means where it's changing from decreasing to increasing or from increasing to decreasing. So number of turning points. If we look at this, we're decreasing until we hit this point, right, everybody? Is everybody comfortable with that? So there's 1 turning point. And then we start increasing until we hit this point. Then it starts to decrease again. So there was 2 turning points. Does everybody see the 2 turning points there? Are we all okay with that? Okay. Now, if with the turning points, I want you to be specific. So I'm going to have you write out your turning points in an XY point. So we know we have to find that using maximum and minimum, right? So let's do that on our calculators. So pull up your calculators. So what we're going to do is, and I'm going to make my window a little bit better. It's a little bit big. All right. Just for my own comfort. Okay. All right. So now I'm going to do, we want to know where the turning points hit, exact turning points. So there's one right there, and that's a relative minimum, right? Isn't that a minimum, everybody? Relative minimum. So remember, you can take your calculator, do second trace, scroll down to minimum, hit enter. Now this part is where a lot of you just think you can randomly scroll around and push enter. You can't. You've got to do it correctly. So it says left bound. So we need to be left of the minimum value. So I'm going to scroll with my calculator and I'm going to make sure I'm left of it. I'm left of the minimum. I hit enter. Then I'm going to scroll right. It says right bound. I got to make sure I'm right of the minimum. Anywhere right. I hit enter. It says, do you want me to guess? Yes. Hit enter again. Our minimum is at -1, -2. So there's one of our turning points, -1, -2. -1, -2. And then I'm going to find the other turning point. So now this is a maximum. It's very important that you type in the correct thing. So this is a maximum. So I do second trace, and I'm going to go down to maximum. Then it says left bound, anywhere left of the max, and I'm left of the max right here. I hit enter. Right bound, I need to be right of the max, and I am. I hit enter, enter again. Our maximum's at 0.999, so that rounds to be 1, 1, 2. Our maximum is at 1, 2. 1, 2. So now I could draw this if I needed to correctly. We had a point over 1 up 2. That was a turning point over -1, -2. There's our turning point. And then it crossed through and it went, our end behavior was up and down. So up and down. Let's see. Yeah. So, I mean, rough sketch is probably fine. Okay. Rough sketch is good enough. All right, so does everybody understand how we have 2 turning points? Here's one of the turning points to the second turning point. Okay, now it says, this is probably the hardest part for students, but it should be pretty easy for you guys. So it says, and the increasing and decreasing intervals. So with this, guys, we're always talking x values. So we want the intervals of x values where our function is increasing and decreasing. So I'm going to focus on decreasing first. So what interval, x values, so these are our x values, is our function decreasing. So isn't it decreasing coming in from, isn't this over here negative infinity on our x-axis, right? So it's coming in from negative infinity till boom, that point, and it stops decreasing, right, everybody? Does everybody see what I'm saying here? So it's coming in from negative infinity, and it stops decreasing at the x value -1, right? We're talking x values. So -1. Now understand something. -1 is not -1, -2, that point. The turning points are not increasing or decreasing. So you can't put a bracket, because that would include it. So we're going to put parentheses around both of these, because once again, that's not necessarily increasing or decreasing at -1. It should stop right there. Is everybody comfortable with that part? Now there's another part where so from here, does everybody understand? I'm going to color code it. We were decreasing from there to there. Decreasing. Does everybody get what I'm doing here? Now we're also decreasing from here to here, right? Isn't that still decreasing? So our x values where we're decreasing is at what x value? +1. And it's decreasing to x values that's positive infinity. So it's decreasing from +1 to positive infinity. Questions on that? So I color-coded it for decreasing. I'll change colors here. So increasing, now we're doing our increasing interval. It's increasing from this x value up to this x value. So x values. Now you knew that these were the points. So x values, it was increasing from -1 up to +1. And we don't include these as brackets because, once again, those turning points are not necessarily increasing or decreasing. They're just there. That's the stopping points. Does everybody get what I'm doing here? Okay. Do we need to do another one? Or are you feeling okay? Another one? It's really kind of up to you guys on how you feel. I have another one if we need to do it. But do you feel like you need to do it? Yeah? Maybe one more? So you want to try it, and then if we need to come back, we can? Okay. So do 20 and 21. If you don't need it, I won't do another example. If so, I'll bring it back to me. Okay, so looking at this one, describe the end behavior, the number of turning points, and the increasing and decreasing intervals. Type it into your calculator. You get, so type it in. It's 1/2, so 1 divided by 2, and then x cubed. Okay, I hit graph, and I get something that looks like this. Does everybody see that? Did you see how I got that? Okay, so my end behavior in words is down and up for this one. Down and up. All right, so then from there, it says the number of turning points. So that means where it changes from increasing to decreasing or decreasing to increasing. Let's look at this one. This one's interesting. Increasing, 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 increasing. Did we ever change to decreasing in this one? No, so there's no turning points. So none for turning points. Then it says, describe the intervals where we're increasing and decreasing. Aren't we only increasing? So decreasing, not never. And then intervals of where we're increasing from negative infinity to positive infinity, right? That's the interval where we're increasing. So everybody see that. So you are going to have times where you don't change from increasing to decreasing or decreasing to increasing. That's no turning points. Okay. All right, one more with turning points. 2x squared plus x minus 3. So 2x squared plus x minus 3. Okay, graph. So we get something that looks like this. It's a parabola. So our end behavior is up and up. Then, number of turning points. Well, let's look. Where do we change from decreasing to increasing? Boom, right there, increasing. So we have one turning point. And we want to know that turning point. So you'll do second trace, and this is a minimum. So I hit minimum, and I go left bound, enter, right bound, enter. So our minimum is at negative 0.25, comma, negative 3-ish. Okay, so negative, that's this point. Negative, if you draw a picture, it helps. Negative 0.25 to negative 3. So then from there, where are we decreasing? Our decreasing interval, x values. So here's our x-axis, right? So we're coming in hot from negative infinity. Ding, 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 coming in, boom, till we hit this x value, which is negative 0.25. Then we start to increase at 0.25, so I'll change colors to increase. So our increasing interval, we're increasing from negative 0.25 with x values up to positive. We're growing this way to positive infinity. So we're increasing from negative 0.25 to positive infinity. Okay, so once again, continue working on 20 through 21. Check with me when you're done. So this is something we've already learned, guys. It'll be a good review for us. So it says, determine the degree of the polynomial, then give the polynomial with the given... Okay. Seriously, guys? Determine the degree of the polynomial, then give the polynomial with the given points. So we have these x, y points, x, f of x. So these are just a bunch of x, y points, and we want to know the degree of the polynomial. So remember, if you guys remember, does anyone remember? Let's see. Yeah, what do you do? Yeah, good. We're going to find, we're going to take differences of our y values, and then we'll see where they're all the same. Good job. Way to remember that. All right, so now it's set up like this. I like to draw it a little bit prettier. So we only need our y values to figure out the degree. So I'm going to draw it like this. 14, 6, 0, negative 4, and negative 6. I just like them set up like this, but it really doesn't matter. All right, so we take the differences of our y values. Now there's one important thing here. You've got to make sure you always take the one that comes before the one above it. So we're going to take 6 minus 14. You've always got to start with the one before. So 6 minus 14. Okay? And then we take 0 minus 6. Negative 6, right? 0 minus 6. And then negative 4 minus 0. Negative 4. And then negative 6 minus negative 4. Negative 2. Are they the same when we took the differences the first time? What? Yes. So order that, yes. What was your question? Okay. So they're not the same, so we'll take differences again. Carefully here. -6 minus -8. Positive 2. -4 minus -6. 2. -2 minus -4. 2. Are they the same when we took differences the second time? So we took them once, twice, so we know it's quadratic, right? So it's 2, degree 2, it's quadratic. And then we just use our calculator to type in the information, and we know the polynomial that has these given values, these x, y values. So you'll type it in. So you do, if you remember I don't have this written down. Does somebody have these x, y points written down by chance? Somebody hurry and write them down for me, or so we can get through this, or yeah. Thank you, sir. Appreciate you. All right, so then we do this, everybody. You do stat, the stat key, stat, and then edit. And then we type into list 1 our x values and into list 2 our y values. So what's our x values?
-4.
-4, enter.
-3.
-3, enter.
2.
-2, enter.
1.
-1, enter. 0, enter. Okay. Then we type in our y values. Now make sure if you have extra stuff in here, I saw a lot of you get this wrong because if you had extra stuff, you didn't delete it. It needs to be the exact values you were given. Okay, what are our y values that match up with these x's?
14.
So positive 14, enter. 6, enter. 0, enter. -4. -6. Does everybody see what I did there? Now make sure your x, y points match up. Then you hit the stat key again, and then over to calculate. Now because it was quadratic, we've got to go down to quadratic. If it was cubic, we would have gone down to cubic. If it was quartic, degree 4, we'd go down to quartic. So I'm going down to quadratic. I hit enter again, enter through. So there's our polynomial. We know it's a quadratic, so it has the form ax squared plus bx plus c. Our a value is 1, our b value is -1, our c value is -6. So 1, -1, -6.
Well, how did you get there again?
1, -1, -6. So we know it's going to be 1x squared, or x squared, minus 1x minus 6. So this is the polynomial with these given values. Is everybody okay with that? We have learned this. You hit the stat key, edit, stat, over to calculate. Okay, do problems 22 and 23. Stat, edit, stat, calculate. Ready, set, go. Okay, next thing, guys, we got to keep moving along here. Okay, so it says, find the zeros of the function, then graph. Well, guys, finding zeros is the whole reason we learned how to factor, and we've learned how to factor a lot of different things. Well, remember, the whole point of factoring is so that we can get down to linear factors, meaning factors that are degree 1, right? So if it's already factored, then it's easy, right? So the whole point of factoring is so we can set our linear factors equal to 0 and solve. So look at my two examples. So we're given f of x is equal to x minus 3 times x plus 4. Should I distribute those through and get a quadratic and have a quadratic? No, because then guess what we would do? We would refactor it, and guess where we'd end up? Right back here. So don't do extra work. Aren't these already linear factors? Okay, so those are linear factors, so we can just set them equal to 0 and solve for x. So we have x minus 3 is equal to 0, x plus 4 is equal to 0, solve for x in each case, add 3. So x is equal to 3. There's one of our zeros, which means that's where it crosses the x-axis at 3, and then x, so minus 4 from both sides. X is equal to -4. So our zeros are at 3 and -4, guys. Now understand something. That means, so x, the zeros are the x-intercepts. So I'm going to go to positive 3, it's crossing the x-axis at 3, and it's crossing the x-axis at -4, right there. Now, this is where I would type it into my calculator because I'm going to be kind of a stickler on this. Now, it is a quadratic, and so we know it's either a smiley face or a frowny face, but you can actually just type it in your calculator like this. So just type it in like that. So type in x minus 3 times x plus 4. So y equals, you can literally just type it in like that, parentheses, x minus 3, close your parentheses, times x plus 4. I hit graph. Now we already know the x-intercepts, we've already graphed them. That's where it crosses the x-axis. We were able to find those because it was already factored. And now what I need you to do is also graph the minimum or maximums correctly. So this one only has a minimum, so I'm going to do second trace, and I'm going to find the minimum so I can graph it really correctly here. So I'm finding the vertex, everybody. I'm finding the vertex. So it says left bound. I'm going to make sure I'm left of that point. I hit enter. Right bound, I'm going to make sure I'm left of that point. And I'm right of it. So I hit enter. It's a minimum, right? This one has the lowest point. So the minimum is at negative 0.5 down 12.25. So our vertex, our lowest point's at negative 0.5 down 12.25. So I'm going back, negative 0.5, and then down. It's off the graph. It's clear down there. But that way, you can draw it pretty accurate here. Does everybody see how I graphed it? Okay. All right, so one more. Looking at this one. Find the zeros of the function, then graph. So we have some zeros here. Now, this is a linear factor, so it's already factored. These are all factored. So we have x is equal to 0. X minus 4 is equal to 0. Now, oftentimes people forget about the x right there. That's a linear factor still, so don't forget to set that equal to 0. And then x plus 3 is equal to 0. Then solve for x in each case. X is equal to 0. It's crossing the x-axis at 0. It's crossing the x-axis at 4. And it's crossing the x-axis at negative 3. So I have it at 0, and at positive 4, and at negative 3. Now I would graph that in my graphing calculator, right here, graph it, type it in, and then I would find the lowest point and the highest point. Because there's going to be, it's a cubic, so it's going to look something like this, but I would need it to be accurate. Or it might look like this, down and up. Anyway, so I need you to graph it in your graphing calculator, find the minimum and maximums. Do I need to do that, or do you get what I'm saying? Okay. Are you sure? Because you've said that 1 or 2 times before today and you really didn't get it. Should I finish this one out? Okay, so if you're comfortable, you can move on, but if not, watch. So we're typing in x times x minus 3, x plus 3, sorry, x plus 3, and then x minus 4. And I hit graph. So we know it's going to look like this, up, down, and then it comes back up. So it's down and up, but I want to know that exact point and that exact point right down here. I'm going to even make my window bigger, just on my Y min and max. I'm going to make it bigger just for kicks and giggles. All right. So then from there, I'll do second trace, and I'll find that exact point and that exact point. So second trace, minimum or maximum. I'll do maximum first, just for fun. So left bound of the max, right bound of the max, okay. So it's at negative 1.6 up 12.5. So my examples I made up off the top of my head. So negative 1.5 up 12. So it's going to be clear up there. So it looks something like this. So my examples I made up and they didn't fit on the graph. But you'll do the best you can. Does that make sense of what I did there? Really? Is that okay? Do you get what I'm doing? All right. So do problems 24 and 25. Have me check them so we can move on. Okay, what is the polynomial? We've already learned this, so I'm going to go way quick, so stay with me. What is the polynomial in standard form with the zeros? -1, 1, and 4. Remember, zeros mean where it crosses the x-axis. Well, remember, to find the zeros, we have linear factors. So once again, if these are zeros, then those are the x values, right? So we have x is equal to -1, x is equal to 1, and x is equal to 4. Well, to be able to get those answers, before that, we have linear factors that equal to 0. So we're going to bring these over to the other side of the equation so we have our linear factors instead of our zeros. Add 1, add 1. So we have x plus 1 is equal to 0. Does everybody understand how this is the linear factor because x is equal to -1? Okay? I'm going to subtract 1. So we have x minus 1 is equal to 0. That was a linear factor. Subtract 4. So we have x minus 4 is equal to 0. So these are our 3 linear factors. Now remember, before we split them up, so we're going backwards. Before we split them up, they used to be multiplied together. X plus 1 times x minus 1 times x minus 4. And they were all equal to 0. Does everybody see how this is going backwards? The other way. Then from there, we would distribute. Now, take my advice. Multiply 2 of them together first, and then multiply in this third one next. So I'm going to multiply these two together and combine all like terms first. X times x is x squared. X times -1 is -x. Positive 1 times x is positive x. Positive 1 times -1 is -1. Before you multiply that in, combine like terms. X squared, those add up to be 0, minus 1. So now we're going to multiply x squared minus 1 to x minus 4. And we're going to distribute again, double distribute. X squared times x is x cubed. X squared times -4 is -4x squared. -1 times x is -1x. And -1 times -4 is positive 4. There's the polynomial that had those 3 zeros. So you're just going backwards. We have learned this before. So hopefully you're okay with that. Do problems 26 and through 28. Ready, set, go. 26 to 28. Okay, we have to finish this. So, everybody, last examples, and then you should be able to finish this. Find the zeros of the function. So guys, most of these are going to be pretty easy, but some of them you're going to have to actually think a little bit. So look at this example. X squared minus 2x. Is it factored? No? But is there something in common in the beginning?
Sure.
An x, right? So this one's easy. We pull out an x. That means divide each term by x. So left is x minus 2. Are they factored? So now it's linear factors. So these are easy, guys. These are really easy. You should be paying attention. So these are now linear factors. Set them each equal to 0 and solve. So x is equal to 0. There's one of our answers. Add 2, x is equal to 2. Is everybody okay with that? That was easy as all heck, right? Everybody? What about this one? Is it already factored? Yep, isn't x minus 2 squared just x minus 2 times x minus 2, and then we have x plus 1 and x minus 3. Are those all linear factors?
Yeah.
So these are easy. Set them each equal to 0 and solve. So we'll get x is equal to 2, x is equal to 2, x is equal to 3. So we know that is x is equal to 2 with a multiplicity of what? A multiplicity, how many times did we get it, guys? 2. So x equal to 2 with a multiplicity of 2. X is equal, that was the worst handwriting ever, x is equal to -1 and x is equal to 3. With a multiplicity of 2. X is equal to 2, since it happened twice, this is the correct way of writing it in secondary math 3. X is equal to 2 with a multiplicity of 2, because it happened twice. If it happened 3 times, it'd be a multiplicity of 3. Does that make sense? You don't just write x equal to 2, x equal to 2. Does that make sense? So then that would be our answer. So guys, these are really quite easy. Are you able to finish problems 29 through 32 now? You should be able to. And you should be able to finish them before the end of the hour. Finish the worksheet. Ready, set, go.